This is lesson 2.3. In lesson 2.3, we're going to continue talking about inequalities and solving inequalities. But this time, we're going to be talking about using multiplication and division when we're solving inequalities. So for example 1, we have the inequality 1/5 W is less than or equal to -6. So as we start to solve this, just like when we had equations, if we have multiplication to start, we're going to divide to solve. This one, because it is a fraction that we're trying to undo the multiplication for, we have to divide by 1/5. But when we divide by fractions, remember, we keep change flip. So I'm going to multiply both sides by 5/1, or in this case, I'll just do times 5. So my 5's cross cancel diagonally. So I'm left with W is less than or equal to -6 times 5 is -30. So when I am going to graph these, remember I need at least three numbers on my number line here. So put -30 in the middle, go one closer to 0, so -29, and one farther, and we'll go -31. So looking at this, I know that it says or equal to, so that includes -30 as one of my solutions. So a closed circle, and it's everything less than -30. So I'm going to move my arrow to the left, everything smaller. In example 2, I have -18 is greater than 1.5q. So again, I want to get q by itself, and I have multiplication, so I'm going to divide both sides by 1.5. So 1.5 divided by 1.5 is 1q. I'm going to record my inequality symbol, and -18 divided by 1.5 is -12. Now, just like we talked about before, if I'm trying to graph this, it is often easier to have the variable be on the left side. So I'm going to flip this so that the q is here. Notice the little side is pointing at the q because the q is smaller than -12. Both of these solutions are true. It's just for graphing purposes easier if that variable is on the left. So I'm going to have -12, -11, and -13. So for this, it's an open circle at -12 because there's no line, and it is everything less than -12. So right now it seems like solving an inequality is exactly the same as solving an equation, but there is a little bit of a trick. So sometimes we have inequalities that have negative numbers. And when, example 3, Mrs. Lover, when we have inequalities with a negative number attached to the variable, notice up here, the 1/5 was positive, 1.5 was positive. When I have a negative number attached to the variable using multiplication or division, that's when things are slightly different than when we solved with our equations. So let's take a look at a couple examples here. So -7y is less than or equal to -35. So the process is the same. So these are attached using multiplication. I'm going to undo that by dividing by -7. That part is exactly the same. No big deal. So y, -7 divided by -7 leaves us with 1y. -35 divided by -7 leaves us with +5. Here's the part that changes. Whenever I divide by a negative number with inequalities, the symbol that we have switches directions. So originally, it was pointing little side to the left, and in the end, it's going to flip, and we're going to be pointing little side to the right. So this inequality actually reads that y is greater than or equal to 5. So when I graph this, it is or equal to, so I'm going to have a closed circle at 5, and it is everything above 5, so everything to the right here. But it's always the number attached to the variable that determines whether or not we are flipping our sign or not, because I divided by a negative number. Up here, in example 1, this number was negative, but it's not the number I was multiplying by that was negative. That one was positive. So even though I got a negative answer, it's the number I'm multiplying by or dividing by. If it's negative, I'm going to have to flip my sign. So taking a look at another problem. Example 4, we have -1/10 z is less than or equal to +1. Actually, this one, instead of an or equal to, let's just make it less than. I think that's what I meant. There we go. Just less than. So, as with before, if we have a -1/10 times z, I'm going to undo that with multiplication. And I'm going to flip, so it's times -10/1, or on the side, -10. So my -10's cross cancel. I am left with z. 1 times -10 is -10. And originally, the inequality was facing towards the little side towards the z. We're going to flip it. That little side faces towards that -10. So it's z is greater than -10. All right, so open circle at -10 and everything above it. And sometimes we have word problems that we can solve using inequalities that have multiplication or division. So let's take a look here. Your friend saves $150 each month to buy a down suit needed for high altitude mountain climbing trip. Describe the number of months your friend needs to save to buy the suit. So our friend is saving $150 each month. We don't know how many months at the moment, right? Because it's asking us right here. Describe the number of months. So that's where our variable comes into play. And down at the bottom of this picture, we've got information about how much that suit's going to cost us. So it looks like $1,249.95. So we're going to take this information. We're going to make our inequality. So it's $150 each month. So times the months. And we know that in order to reach our goal of $1,249.95, that we have to earn this much money or more. So this is the smallest amount of money that we can have for our savings here. So it has to be this much or more. Okay. So now we're going to solve. We're going to divide both sides by 150. 150 divided by 150 is 1 m. 1,249.95 divided by 150 is 8.333, kind of keeps going, repeating 3. Since I divided by a positive number, my inequality symbol stays the same. I don't have to change the direction in any way. So what this is telling me is it's going to take me at least 8.3 months in order to save this. So if I'm saving that $150 at the end of the month each time, right, maybe it takes me the whole month to get the $150, I'm not going to be able to afford it partway through the month. So I am going to have to save, or my friend in this case, my friend is going to have to save at least 9 months in order for us or for that person to buy this down suit for their mountain climbing trip. Apparently, that's an intense suit for some mountain climbing, but it's going to be very cold at the top of the mountain. This is lesson 2.4. In lesson 2.4, we're going to be continuing to talk about inequalities and solving inequalities, but this time we're going to be working with solving multi-step inequalities. For example 1, we have y over negative 6, there we go, let's mark y, plus 7 is greater than 9. So just like we've done in the past, if we have both addition and subtraction along with multiplication or division, we're going to undo the addition or subtraction on the variable side first. So I'm going to subtract 7 from both sides. So this makes our 0. We're going to bring down this y over negative 6. Inequality symbol stays the same because I'm just subtracting 7. 9 minus 7 is 2. I'm going to multiply both sides of my inequality by negative 6. So negative 6 and negative 6, those cancel another diagonally here. So I'm left with y. 2 times negative 6 is negative 12. Remember, since I multiplied by a negative, I have to flip my inequality symbol. So I have y is less than negative 12. For example 2, we have 6x minus 5 is greater than or equal to 2x plus 11. So this time we've got variables on both sides of the inequality, similar to when we had them on both sides of the equation, but I'm still going to start with getting all of my plain numbers onto one side. And since I like to try and keep my numbers positive if possible, I'm going to add 5 to both sides. So negative 5 plus 5 will cancel. I have 6x. All I did was add, so my inequality symbol stays the same. Bring down this 2x. 11 plus 5 is 16. Now I have to move my variables to the same side. So I'm going to subtract 2x from both sides. 2x minus 2x is 0. Bring down the 16. Again, just subtraction, so the inequality symbol will stay. 6x minus 2x is 4x. Guess I should have made that one yellow as well. Now I have to undo my division. So I'm going to divide by 4. 4 divided by 4 is 1x. Now notice I divided by a positive number, so my inequality symbol again stays the same. 16 divided by 4 is 4. So x is greater than or equal to 4. All right. We're also going to talk about some different circumstances for solutions. So in equations, we had different circumstances where we had things like no solution, infinitely many solutions, or all real numbers, we sometimes refer to it. So we're going to look at some of those instances for inequalities as well. So for example 3, we have the inequality 8b minus 3 is greater than 4 times the quantity 2b plus 3. So just like in equations, the first thing I need to take care of is to distribute all possible parentheses. So 4 times 2b is 8b. 4 times 3 is positive 12. None of this stuff over here got used, so we're going to bring it down. And something to keep in mind, when we're distributing our parentheses, even if this number here is a negative, it doesn't have anything to do with our symbol. The symbol changes when we divide both sides or multiply both sides of the equation by that same number. So like when we're undoing, so like division where we had here, or in this case, multiplication that we had here, when we're undoing them, that's when the symbol changes. So make sure you're not confused or accidentally changing it when we shouldn't. All right, so I'm going to start my next step by moving my variables to the same side. So I'm going to subtract 8b. 8b minus 8b is 0. Bring down my 12. Bring down this negative 3. 8b minus 8b is also 0. So there's my inequality symbol. It didn't change. I haven't multiplied or divided by any negative numbers or anything like that. So when I look at this, negative 3 is greater than 12. Is that a true statement? No, this is not true. Because it's not true, we would say that this would be a no solution. So we're looking to see, is this a true statement or not a true statement? Negative 3 is not greater than 12, so this would be no solution. For example 4, we have 2 times the quantity of 5w minus 1.2 is less than or equal to 7 plus 10w. So again, we're going to start by distributing our parentheses. 2 times 5w is 10w. 2 times negative 1.2 is negative 2.4. Inequality symbol hasn't changed. We haven't done anything with 7 plus 10w, so we're going to bring that down. Next, I'm going to subtract 10w from both sides. 10w minus 10w is 0. Bring down our 7. Inequality symbol doesn't change. Bring down this negative 2.4. 10w minus 10w is 0. So now I ask myself, okay, is negative 2.4 less than or equal to 7? Yes, this is true. So because this is true, we would call this all real numbers. And what that means is that every number that's a real number could be plugged in for w, and it would make it true. If you're asked to graph something that is an all real numbers type of situation, 1, 2, -1, -2. So in an all real numbers type of circumstance, the entire graph has a number, that would be true. So basically what you would do is you would do arrows on both ends of the graph because it goes in both directions to infinity essentially, and it's the entire graph that's graphed. So arrows both ways, whole graph is covered. And for example 5, you're playing a trivia game on your cell phone. You need a mean score of at least 90 points to advance to the next round. What scores in the 5th game will allow you to advance? So we want to move on in this trivia game. We know we have to have at least 90 points, where that means 90 or more, to move on to the next round. We also know that the scores we have so far are recorded right here on this cell phone. It also is important to note that they're talking about the mean score. And remember, we talked before that mean means average. So the average would be adding all the scores together and dividing by how many games we've played. So if we're looking for the 5th game, we're going to be dividing by 5 games. All right, so at least 90 points, which means we've got 90 is the lowest score that we want to get. So we know that it's going to be greater than or equal to. And then we have to add all of the points from the phone. So we had 95 plus 91 plus 77 plus 89 plus that amount for the 5th game that we don't know yet. So we're going to call that one X. Give it a color so we can see it better. And since it's the average, we got to divide this whole thing by 5. I'm going to make my 5 in green so that, because we on the paper over here noted that the average was in, I used green, so I used 5 to show that. All right, so before we start doing all of our solving, let's simplify a little bit. 95 plus 91 plus 77 plus 89 is going to give us 352 plus our X. Don't forget about that X, because a lot of people forget to bring it down when we're doing stuff like this. Nothing changed about our inequality symbol. Nothing changed about the points. Still an average, so it's still over 5. Now remember, when you have something with an addition or subtraction problem at the top of a fraction, it's as if these are in parentheses. So we want to take care of undoing this division before we try to worry about the addition and subtraction that's on there. So we're going to multiply both sides by positive 5. Because remember, it's like 5 over 1, which means the 5s will cross cancel. So we're left with 352 plus X is greater than or equal to 90 times 5 is 450. Now we can take care of that addition. So we're going to undo our addition by subtracting 352 from both sides. 352 minus 352 is 0. Bring down our X. Greater than or equal to 450 minus 352 is 98. So that means on game number 5, we have to score 98 points or more in order to move on to the next level or the next round that we're able to play. This is lesson 2.5. In lesson 2.5, continue talking about inequalities, but now we're going to be moving on to talking about compound inequalities. And if we look at the definition here at the top of this note sheet, a compound inequality is an inequality formed by joining 2 inequalities with the word and, which talks about like an intersection. So it means it's a solution for both parts, or the word or, which is referred to as a union. And in a union, it can be a solution for either one of the parts. Okay, so we're going to kind of look at first what the graph would look like for a compound inequality. So if we started with x is greater than -8 and x is less than or equal to 4. So on a number line, I need to make sure that I have both numbers on here. So for example, this one has -8 and positive 4. And then I'm going to put 0 in here as well because it fits between those two. So when I look at it piece by piece, I have x is greater than -8. So that's an open circle at -8 and everything above. For the second part, I have x is less than or equal to 4. So closed circle and everything below. But my solution, since it says and, it's talking about the overlap. Let's use green for and. So this is talking about overlap. So if I look at it, overlapping, I know there's an open circle at -8 and a closed circle at 4, and it's everything in between. So my solution is the spot that overlaps. For example 2, we're going to look at y is less than or equal to 0, or y is greater than or equal to 3/2. So again, on my number line, have to make sure that I have 0 on here, and 3/2. Let's do it this way. So this will be 1 whole, half, -1. All right. So for that first piece, I have y is less than or equal to 0. So I know it's a closed circle at 0 and everything below. Or y is greater than or equal to 3/2. So half, 2/2, 3/2. So again, closed circle, and this time everything above. So for an or scenario, notice they don't overlap each other. This is what we call a union, but there's no overlap. And they kind of go in opposite directions of each other. So I could say -1, since it satisfies this here. Or I could say that a solution is +2, because that would satisfy the solution over here. So it doesn't have to be both. For an or, it's either or. Okay, so it's not both, either or. And is overlap. That means it has to be true for both things. So for example, 0 would be true for both in this one over here. All right, now, when we're talking about solving compound inequalities, for this one, we're going to solve our compound inequality as x. -4 is greater than x minus 2, which is less than So this inequality is really made up of two separate pieces, right? I have this side here, which is everything to the left of my second inequality symbol. And then I have everything on this side, which is everything to the right of my first inequality symbol. So I'm going to split it into two pieces. So I have -4 is less than x minus 2, and x minus 2 is less than 3. And then we're going to solve them, just like we've been doing already. So over here, I'm going to add 2 to both sides. Those cancel. I'm left with x is greater than -4 plus 2 is -2. And over on this side, I'm adding 2. So those will cancel. I have x is less than 3 plus 2 is 5. So x is greater than -2 and x is less than 5. One way about and compound inequalities is we actually can put them together as one, kind of the way that we started up here. So if I put it together as 1, the variable goes in the middle. And then I copy this part here. So greater than -2, less than 5. So this is my most simplified way to write my solution for that one. For example 4, I have -3 is less than -2x plus 1, which is less than or equal to 9. So another way that I can solve a compound inequality that is an and inequality, instead of making 2 separate ones, I know there are some people who try to use as little space as possible. I can also just separate this into 3 columns. Now, remember when we're doing 3 columns, you're looking in the middle, and I'm saying, okay, goal is to get x by itself. I have to get rid of this plus 1. So I'm going to subtract 1. Now, we're used to subtracting 1 on both sides, but if you leave it as one compound inequality, each column has to have the same thing. So 1 minus 1, those are going to cancel. I have -2x left in the middle here. 9 minus 1 is going to give me 8. Inequality symbol is staying at the moment. -3 minus 1 gives me -4. Inequality symbol stays. Now I'm looking again in the middle. Got to get x by itself. So I'm dividing both sides by -2. Actually, all 3 sides. So -4 divided by -2 is +2. And remember, since I divided by negative, I have to flip the sign. -2 divided by -2 is 1x. So x in the middle. 8 divided by -2 is -4. And again, flip that symbol. So when I look at this, oftentimes when we read them, we read from the smallest number to the largest number. So a lot of times we'll flip the entire thing around, just like we've done in the past. So -4 less than or equal to x, which is less than +2. So both of these are considered solutions, but the one on the bottom is the one that you'll see most often. They'll list it from the smallest number to the largest number. Example 5, we have an or scenario. So for this one, we're trying to solve again. And we're solving 3y minus 5 is less than -8, or 2y minus 1 is greater than 5. Now this is an or, so it's not really one that we're going to solve together in 3 columns like we did for the first one. You really do truly have 2 separate inequalities to solve. So we'll start over with this one. I'm going to add 5 to both sides. So these are going to cancel. I have 3y is less than -8 plus 5 is -3. Divide by +3. 3 divided by 3 cancels. We have 1y. Nothing changes about my symbol because I divided by a positive number, so less than. -3 divided by +3 is -1. Or, now we'll go on to this side. So I'm going to start again. This time I'm going to add 1 to both sides. Bring down this 2y. Greater than. 5 plus 1 is 6. We're going to divide both sides by 2. Again, dividing by positive, so my symbol can stay the same. Y is greater than 3. So we have y is less than -1, or y is greater than 3. And for example 6. For example 6, it says, an electronic device may fail outside if its operating temperature range. Let me start over. An electronic device may fail outside of its operating temperature range. Write an inequality that represents the possible operating temperatures in degrees Fahrenheit of the smartphone. Then describe a situation in which the phone may be outside the operating range. So, looking down here at the bottom, our operating temperature is 0 degrees Celsius to 35 degrees Celsius. Okay, so we know that we're going from 0 degrees as the low, and it can be 0, so it's or equal to, and I'm going to use C for Celsius, but it has to be less than or equal to 35 degrees Celsius. But the problem is, this question asks us to find it in degrees Fahrenheit. So we have to go back to our common formulas and remember that to convert from Celsius to Fahrenheit, we are going to have 5/9 times our Fahrenheit temperature minus 32. Currently, everything else about my inequality is going to stay. So less than or equal to 35, which is a Celsius temperature. Greater than or equal to 0, which is again a Celsius temperature. So we're going to solve for degrees Fahrenheit. Remember, if I want to undo multiplication with a fraction, I have to multiply by the reciprocal. So I'm going to be multiplying both sides by 9/5. And this is one where we have our 3 columns. So we're going to multiply 9/5 here and 9/5 here. I'm going to make 35/1 those 2 fractions. All right, the 9's cross cancel, 5's cross cancel. We are left with f. Oops, I'm going to lower that down a little bit. F minus 32 in the middle. Less than or equal to, because we're multiplying by a positive. The 5 goes into 5 once, and the 35 7 times. So 7 times 9 is going to give us 63. 0 times anything is 0, so that's going to stay, and my symbol stays. Now I'm going to add 32 in all 3 columns. So -32 plus 32 is 0. I have my Fahrenheit, or F in the middle, is less than or equal to 63 plus 32 gives us 95. And it's greater than or equal to 32. So if I shrink this together a little bit, 32 is less than or equal to Fahrenheit temperature, which is less than or equal to 95. So that's our range of our operating system, right, for our phone to work. But let's say it's a really hot day outside, and inside your car where you forgot your phone, even though the temperature outside might be 95, inside your car, it always gets way hotter. So maybe it's 115 inside your car where your phone is, and then your phone would fail to work properly because it's outside of that range that it's supposed to work in. This is lesson 2.6. In lesson 2.6, we're going to be talking about absolute value inequalities. And basically, we're still talking absolute value, so it is about the distance that something is away from 0. So the absolute value of x is less than 2, means that the distance between 0 and x is less than 2. So it could be 1, right? It could be 1.5, but it's less than 2 for that. So this is a graph of the and inequality here. And then if we have an inequality where it says the absolute value of x is greater than 2, means the distance between x and 0 is greater than 2. So it could be a number that is less than -2, right? So -4, that distance is 4. Or it could be above 2, so +4, the distance is still 4. So for this greater than, we have an or scenario here. We can also solve for absolute value inequalities. So we've got a couple of rules here just to kind of keep in mind. When we're talking about our less than here, we've got our and, just like we talked about up there. And when we have a greater than, we've got an or, like we talked about down here. And just like when we were solving absolute value equations, if we have, when we have our two scenarios, we have to make sure that we are putting down exactly what it is, right? Ax plus b is less than c, so that's what it is. And also the opposite of what it is. So here, we flipped the sign, right? Because we're multiplying c by -1. So we flipped the sign, and c is negative. Same thing down here. Even though it's an or situation, we start with the first one, which is what it is, right? Ax plus b is greater than c. We have that here. And then we have to do the opposite. So I have to flip the sign again because I'm multiplying by -1. And then we have, so now less than -c. So let's put this into action, kind of look exactly how to do some of these problems together. So for example 1, we have the absolute value, x plus 7 is less than or equal to 2. Since this is a less than, we know we're going to be working with and. So we have to do exactly what it is. X plus 7 is less than or equal to 2. And the opposite. So remember the x plus 7 part stays. And it's greater than or equal to -2. So we flipped our sign and we changed +2 to -2. So now we solve. We're going to subtract 7 from both sides. So we have 0 here. X is less than or equal to 2 minus 7 gives us -5. And on this side, we're also going to subtract 7. So that makes 0. We have x is greater than or equal to -2 minus 7 is -9. So if we put this into one big compound inequality, remember we put x in the middle. So we know that x is greater than or equal to -9, but less than or equal to -5. So if we're going to graph it, this is one of our and scenarios. So we have on our number line, -9. We also have to have -5. I'll just throw 0 on there for a third number. So close circle for both. Since it's an and, we know what the distance between these two things. All right, for example 2, we have 2 times the absolute value, 3w plus 8 minus 12.5 is less than or equal to -4.5. Now, remember from when we were solving equations that were absolute value, we can't split it into two different things until we have just the absolute value portion left. So before I'm there, I need to add 12.5 to both sides. So -12.5 plus 12.5 is 0. We're going to bring all this down. -4.5 plus 12.5 is 8. We still don't have just the absolute value portion, so I'm going to need to divide by 2 on both sides. Okay, so those 2's cancel. Now I'm left with absolute value, 3w plus 8 is less than or equal. 8 divided by 2 gives us 4. So now that I only have absolute value, I can split it into my two parts. So exactly what it is, 3w plus 8 is less than or equal to 4. Since it's a less than, we have an and. 3w plus 8 now is greater than or equal to -4. So we're going to solve. And in fact, I'm going to do 2 at a time because it's the same equation now for inequality. So I'm going to subtract 8. So this gives us 0. We have 3w left over. 4 minus 8 is -4, less than or equal to. 0 here. 3w greater than or equal to. -4 minus 8 is -12. Last step, we're going to divide both sides by 3. Now, notice we're dividing by a positive number here, so no sign flipping has to take place. So w is less than or equal to -4/3, leave it as a fraction. And w is greater than or equal to -12 divided by 3 is -4. So again, if I want to put this into one compound inequality because it's an and, I have w in the middle, and we know that w is less than or equal to -4/3, but greater than or equal to -4. For example 3, I have the absolute value, 10 minus m, is greater than or equal to -2. So when I look at this, I want you to think back to when we were talking about absolute value and negative numbers, right? A distance can't be negative, but we're talking inequalities, right? So we know that the distance, this absolute value, is always going to be greater than -2. It's always going to be greater than that because it's a distance, right? So for this instance, we're going to say all real numbers, because it's true for all real numbers that it's always going to be, that absolute value is always going to be greater than -2. All right, for example 4, we have 4 times the absolute value, 2x minus 3 plus 1 is greater than 17. Now this one, again, we have to get it just to that absolute value before we can try to split. So we're going to start by subtracting 1. We'll bring all the rest of this down. So we have 4 times the absolute value, 2x minus 3 is greater than 16. Still don't have just absolute value, so we're going to divide by 4. So we're left with the absolute value of 2x minus 3 is greater than 4. All right, so we're down to just absolute value. It's a greater than, so we know that it's going to be an or scenario. So 2x minus 3 is greater than 4, or 2x minus 3 is less than -4. Okay, so we're going to solve each of these inequalities separately. So we're going to start by adding 3. Actually, these are the same steps here, so we might as well do it at the same time. So these cancel. I have 2x left over. Is greater than 4 plus 3 is 7. Here, I have 2x is less than -4 plus 3 is -1. We're going to divide by 2. Again, 2 is positive, so no need to change the sign. X is greater than 7, or 7 halves. Or x is less than -1/2. So if we're using, excuse me, our number line, then we have arrows going in both directions. Let's put that up here for us. So we have -1/2, and we have positive 7 halves. Open circle for both. So it's greater than 7 halves, but less than -1/2. I should say or less than -1/2. All right, so for example 5, we're going to talk about absolute deviation. And absolute deviation is a number, x, from a given value, is the absolute value of the difference of x and the given value. So I take x minus the given value, absolute value of that, to get my absolute deviation. So, for example 5, a mountain climber wants to buy a new camera drone to help map out a safe route to a mountain summit. The table shows the prices of several camera drones. The climber is willing to pay the mean price with an absolute deviation of at most $100. How many of the camera drone prices meet this condition? So we have to figure out the mean for all of these things. So when I add up 890, 650, 660, 450, 725, 750, 370, 670, 650, 825, add all those together, we get $6,640. But we want the mean. So we have to divide it by the number of cameras. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when we do that, we get $664. So this is our mean. That's what we're going to be using in our deviation here. So I take this x that we don't know minus our given value. Given is our mean. Absolute value. And it says at most $100. So $100 or less. Okay. So we know $100 is the most or less. Since it can also be 100, it's an or equal to. There's nothing added or multiplied or subtracted or anything like that outside that absolute value. So I can go right ahead and split it into its two parts. Since it's a less than, we know that it's going to be an and situation. So x minus 664 less than or equal to 100. And x minus 664 greater than or equal to negative 100. So we're going to solve. Add 664. So this gives us 0, 0. X is less than or equal to 764. And x is greater than or equal to 564. So we know that x has to be less than or equal to $764, but greater than or equal to $564 in order to meet these standards for our camera purchase.